Recording. Okay, so thanks everyone for joining. So we will have two presentations this morning. The first one is from Atlantique, that the researcher in XR that will present his work on at ETS. So ETS is a Master of Engineering School, to simplify a bit. And he will present his work on XR, and then we will have Agus that is here local at Nantes for again for 2 weeks now. Yes.
3 weeks.
3 weeks. Okay. He will talk about AI and how they do and what they do at ETS in Indonesia. So, Adzik, I let you begin your presentation.
All right. Thanks, Aurelia. Can you see my screen right now?
Yeah, it's good.
Great. Yeah, let me start with this. So, explaining the circumstance, your position in Nantes, right? I don't know how to pronounce it exactly. So this is your position right now, and I'm here. We are separated about 21.5 hours if you want to go to my location by aeroplane. The name of our university, me and Agus, is called Institut Teknologi Sepuluh Nopember. Am I lost? Is it okay now?
Yeah.
Let me check. Okay. So this school, this university is located in this island. Okay. The most populated island in the world. I bet so. So Java. So if I move back in here, sorry, I'm losing my control on my slide. Okay, so this island is the world's most populated island in the world. It occupies. There are about 3.5% people chilling here right now, and it's called Java. And perhaps you know this word before. Java is a programming language found by James Gosling, one of the founders. And why it's called Java is because Gosling loved to drink coffee that comes from this island. It's quite interesting fact. Maybe some of you just know this fact by now. To be exact, I'm now in the city of Surabaya, and this is our university. This campus is about 1.8 kilometer per square area. Kilometer square area occupies this area in the city of Surabaya. From above, this is our campus looks like. So there are still quite a lot of trees, and I think still have a lot of possibility that there will be more building here. And we have a lot of engineering school inside. And me and Agus is right now is in this particular location. So we are working in here in this building. Aurelia back then also taught us some materials in virtual reality, standard reality on that building. Just a bit about our campus. And let me move to the next slide. So today, I would like to talk something about extended reality, specifically on how to enhance training and learning. And these materials are based on our user studies. We administered, we carried out just this year, and we published just last month. If you want to check two of our conference publications, I worked on these two papers together with my master students, and we published this work on international conference on cyber words in Yamanashi, Japan. Later on, after I talk about these two research that we have just done this year, we are also would like to talk about a bit on our undergoing project, this ASA VR, the project for dementia care education. Just a bit about some progress, and hopefully later the audience in this meeting can give us some feedback as necessary so we can develop a better research progress later on. Okay, let's start with the first one. So it's all about AR for fire safety training. This safety training was done particularly for students, high school students. Okay, we believe that educating the public, including the students, on fire safety through simulation, just like augmented reality or virtual reality, is crucial, is important for mitigating losses and saving lives. It's based on this work by San and Turkan in 2020. And thus, we would like to do some, we have done some user study with our students. Not my students, actually. This is the students of my master students. That is located in Riau Islands. So there is an island that is kind of close to Singapore. It's about this place. My location is actually in here, so it's a bit further. So I need to take airplane. I need to take a flight to go to this location. But my student managed everything, including the user study, the development, etc. I just advising him to ensure that the research going well. So in this research, we invited 20 students, picture is on the slide, with such demography. So there were 16 male students and then 4 male students that half of them has a previous experience in augmented reality, including playing Pokemon Go or like playing Instagram as well is considered as a AR applications. But some of them, half of them to be exact, never done or never played AR in their life. So this is basically the background of our participants. And to all of those, each one of those students, we asked them to do this procedure. So starting from this huge room, the student lab, we asked them to stand here initially, and then learning about the crisis handling phase, first one, and then moving to the next room. The second phase is to turn off the electrical switch. This is to avoid further fire risk due to the electrical system. This is quite important in fire safety training. And last but not least is evacuation. So moving out from this building by quitting through this door. So these are 3 simple steps that we require from the students to do in this fire training. This is the application that we developed, the application. Sorry, this is in Bahasa, but hopefully you got the idea. So we give some instructions in a spatial display about how to help yourself quitting or evacuating from this disaster. And we have a fire simulation in the room, and we would like to teach the students how to utilize wet fabrics, wet clothes, to turn off the fire. And then after that, we navigate them to the next room. Let me fast forward. And then we give another spatial hint to turn off the electrical switch. And they were required to turn off actually the physical switch in the building. And then last but not least, they will need to navigate themselves to go out from the room by exiting through this door. Okay, so getting outdoor is the final step, and it's done. So this is the procedure that they need to pass, each one of the students. During the experiment, we separate the group into two, and then asks half of the students to just learn the procedures from the video that we provided, and then half of them we ask them to play the AR simulation applications that we developed. Okay, so and then we compare these two. It's quite simple, actually, this user study. However, we would like to contribute more by providing a bit complex measurements. So it's not just about measuring the performance, but we focus on these three categories of measurement: the self-efficacy, the motivation, and the knowledge. So we have two groups. We apply different treatment to these two groups: video watching or using AR to experience the fire safety training. And then we will give them some post-training questionnaires right after the training or the video watching. And after that, after 2 weeks later, we ask the same questionnaires to check the results, whether the retention was there or not across the participants, across the students. And as a result, so in terms of or regarding the knowledge and the motivation, self-efficacy, this is what we got. The difference is quite significant, as you might see it in this box plots. So the gap is for real. This post and this retention, by the way, is not the actual post or retention. This is kind of the subtraction from the pre-test. So we subtract the pre-test from the post-test score, and then we got this, like the distance, and this distance is quite significant. The blue one is the video, the orange or this brown one is the simulation through the AR. As a takeaways, you may check the details of the results in this paper if you want, its.id/CW1. The takeaways from this particular research: we learned that AR-based training can significantly enhance the knowledge of participants. In these terms, the students, also the motivation and the self-efficacy of them. And we can conclude as well that this AR can be a powerful tool for improving the learning outcomes. But its effectiveness, we observe that the effectiveness across participants still varied. So it requires future work to check this, how to make sure that the effectiveness can be better. That's from our first publication. The second one is still about education. Now we talk about the geography learning in VR, especially. The title of our paper is Exocentric Views Are Superior for Learning Geography in Virtual Reality. I will explain about what is exocentric and what is the counterparts, the egocentric, in the next slides. And I will also explain about what is the reference frame meant here. In our research, we use VR to enhance geography learning by comparing the reference frames. Traditionally, students use globes, physical globes, and paper-based maps to locate countries and to understand the Earth's layout, knowing the capital city of some countries, etc. They rotate the globe, pinpoint the location, etc. Yet it requires spatial reasoning. In VR, by the way, some of you have used something like Google Earth, something like that. The reference frame may vary. And here we would like to investigate whether the head, the body, or the virtual world reference frames are preferred by the users. And also we measure the performance, the task completion time across the participants, across the users. There are three research questions that we focused on this research. The first one is which one of the reference frames that can enable the fastest task completion, the task completion time. The second one, which reference frame that offers the best learning experience and satisfaction. And the third, which reference frames that motivates the students the most. So these three questions will be answered in the takeaways in the later slides. The previous research was done in Tanjung Pinang in Riau Islands. This research, by the way, is also done in another location. It's not in Surabaya, but still considered close. It's about 100 kilometers, so just 2 hours drive from the city of Surabaya. So it's located here. And this is my master students. He managed to invite 24 students to join this study. And all of them, by the way, never use VR. This is the procedure. The first one, we asked the participants to play test the VR app. And then we did some interview. We asked them to fill the NASA Task Load Index survey. And then there was also knowledge post test filled out by the participants. These are the example of hand reference frame. Hand reference frame is one of the egocentric reference frame. We call it egocentric because the reference is as the part of the user's body. So we may consider that as egocentric. We put the globe in this case in, let me replay this. We put the globe is exactly on one of the participant's hand. And the other hand will be responsible for manipulating the globe. So that's the first reference frame. The second one is, I'm sorry, this one, a body or torso reference frame. A body reference frame means that this globe is located just kind of in the front of the user's belly, in front of his stomach. Okay, so it's a static in here. So if the user seeing to the right side, to the left side, turning their heads, the globe will stay there in the front of the belly. Okay, so imagine that having these two, having this globe in the belly means that we can give these two hands more freedom to manipulate the object. So that's the second reference frame. And then the third reference frame, the users can even move their body freely. So in addition to the right hand and the left hand now can manipulate in higher degree of freedom to the globe, the users can also move freely in the playing area. So imagine that the globe is located in the center of the room, for example, and then your user can move around. So instead of spinning the globe, rotating the globe using the joystick, they need to circle around the globe to check other locations or other sides of the globe. So that's a virtual world. So we have these three scenarios of reference frame in this virtual reality for learning geography. And additionally, we also check the performance of the users, the students, when they use this physical globe. So we also check the performance and also the preferences later. In this experiment, we have 1, 2, 3, 4 groups, and this is the sequence. The sequence is to ensure that we can counterbalance the results. Okay, and in here, there were 4. This is just for examples. So we list out the 4 country names in the task, and this is the image hint displayed to the users. So the user the users saw this image first, and then later on they would like to they would need to pick up the globe or check the globe to find the location. So that's the task. And as a completion time, as you might see in here, the exocentric one is more efficient. Okay. And speaking about the box plot, the difference is also quite significant in here, as you might see in here. And to be honest, this is, I think it's not really surprising. They perform the best in physical globe. It seems that perhaps this is just a matter of discussion. They will need to spend some time to get used to use the virtual reality, because all of the participants in this study never used VR before. But still, we asked the users to pick among the reference frame in the virtual reality, which one is the best for them. They say that they say that the virtual world reference frame is the best, and they navigate them better in their opinion. Hand and body frames, unfortunately, in their opinion, are not typical, so they also not prefer to use this type of reference frame from learning geography. Speaking about the workload, it's quite interesting in here. As you might see, the body is demanded less workload compared to others. Okay, and the globe and the hand is almost the same. Yet the virtual world is in the middle. As the takeaways, the first one, for learning geography, exocentric, and to be specific, when we speak about virtual reality, where the virtual world reference frame outperformed the egocentric ones in terms of speed and the ease of use. And as to answer the second question, although more physically demanding, exocentric views result in a faster task completion. Third takeaways, the conventional globe is still the fastest reference frame, as you might see in the previous slide, but lacks the immersive benefits of VR. For more details, you might download the author version of this paper from this link, its.id/CW2. And last but not least, I would like to mention our undergoing project, ASA VR, or Awareness Simulation Adventure. We specifically developed this application. Right now, we are developing this for dementia care education. So we work together with University of Tokyo and Universitas Airlangga. It's also located in Surabaya, to study about this issue. Because in Japan, the population is aging. And I believe perhaps in all of the countries in this world is also the same. So we consider this issue as important. So we developed this application to improve or to increase the awareness among society, not only the caregivers or the nursing students that have a specific jobs caring for this elderly, but I believe that this project later will be benefit public as well, the society, all the people in the community. As a glimpse, so this is the application. By the way, the demo is in Bahasa for now. So in this application, we will meet an NPC. So this is a VR environment, virtual environment, and we will meet this NPC. I will need to talk and interact with this NPC. So this NPC will say something, will express some sentences, and then this is our assistant Asachan will give hints to us about what should we do the next. Okay, so this is the sentence spoken by the NPC, and it may vary because this NPC is connected, or we linked it or her, sorry, because this is a female elder, with LLM, with a large language model. And to respond to her saying, we can say anything, and then we will proceed the response from the users through the LLM, and the NPC will respond back. So that's the idea. So that's basically what we are currently doing. And what I was inspired by a guest lecture by Aurelia 2 months ago when he visited our laboratory. So to try to track the users better in virtual reality, but unfortunately we are still learning about how to utilize the Microsoft PSI, the platform situated intelligence. However, during our development recently, we also found an alternative. I'm not quite sure whether the teams in France has explored this one or not yet. It's called a cognitive 3D, and we later would like to compare this with the PSI as well, which one is best or suitable for our project. But all in all, this cognitive 3D or the Microsoft PSI we would like to use them to log the activities of the users, all of them. And this is part of the activities. So for example, this one, the log storyline, the log input, the voice input, I mean, and then the discriminator, the response from the AI, etc. So all of them will be recorded. And also the motion. So the X and Y, the direction of the gaze of the users will be also locked. Maybe it's going to be very important during analysis. So this is what we are currently doing, and hopefully we can manage it together with the University of Tokyo and then UNER by next week. And we are quite welcome as well if later there's a possibility for IMT to work together with us in the same domain. That's all from me. Merci.
Thank you, Atlantique, for this presentation. Do we have questions in the room or in the WebEx? Yeah, Yannick.
Okay, hello, I'm Yannick Priguet. Thank you for this presentation. For the last presentation, I didn't really understand where was the dementia thing, because that's about meeting people and having a storyline, but where is it focused on dementia? Where is it?
Yes, you spot it very well. Yeah, I forgot to underline that part. So that NPC is the elderly. Okay, so NPC is the elderly. And the target of this application is for the, primarily right now, is for the caregivers. Okay, to train the nurse, to train the caregivers how to behave appropriately, how to act appropriately on the elderly's response or the elderly behaviors. So we try to model the NPC that is linked with the LLM on that virtual reality to be a dementia patients. Okay, so they are the dementia patients, the elderly. We did this because from our literature study, we found that, and also from the environment in Japan and also across the world, across the globe, that many people behave incorrectly to the elderly. Okay, so we would like to build an empathy. We would like to make sure that these target users will change their behavior after playing this VR game. So they will learn by errors if they behave inappropriately, and we will teach them through the NPC how to make it better. And as you might notice in the virtual reality, that NPC has health points like that 5 hertz icons. And if the users respond inappropriately, the hurt will reduced, will gone. So it reduced the points. So we would like to indicate that their response, this user's response, is inappropriate, and they need to fix that. They need to learn something from the scenario. Hopefully that answers your question.
Another one?
I have another question with regards to the first presentation with the fire alarm. I wonder if it's about the conditions, because watching a video and AR, at some point you could also watch the video and go to the electrical board and switch the electricity, for instance. So at some point, the AR students, they moved and they did physical activity while the other just stayed and watched the video. I wanted to be sure about that. So maybe retention is not related to AR, but mostly to the fact that they moved and acted in the world. That's an hypothesis.
That's correct. So what you wondered is correct. So there are 2 groups. There were 2 groups. The first group is just watching videos. They are not moving at all. So they are sitting and then watching the videos and learn something from the videos. And the second group, we demanded them to move based on the route that we designed in the sequence, and bringing the phones to view the things in AR. And you're right, it is very likely and it's very possible that the retention and all those knowledge is better in the second scenario, because they move and they experience that for real. So that might be one of the reasons, and we also discussed that. We also mentioned that in our discussion. So I believe that this is not the end for our research. We would like to refine our experiment design, and we understand that this weakness, and to make sure that the good retention was obtained, whether due to the movement or the AR is required a further investigation. Thank you.
Yeah, I mean, today a lot of safety procedures, at least when you arrive in a new position in a new company, a lot of things nowadays are made with online training tools, and you had a lot of video to watch. So your paper might be a good demonstration that people should not learn with video-based training for safety, because it doesn't help
memorize the procedures.
But what I said was that you could have the video and go to the switch as well.
Ah,
Without air.
But then why not doing air?
Yeah. Can be interesting
Yeah,
to test both.
that's good point. Yeah, I think we should design a 3 level of apparatus. So one is just watching video and stay still, watching video and do something, right? So as you suggested, and then the other one is playing AR and do the things. Yeah, I agree with that. That's a good idea to ensure that and to make sure that the results should be not, it will not be or lesser bias. Yeah, I agree. That's a very good
In a
suggestion.
way, it's a good opportunity to tell people in charge of emergencies training to stop using video to train people.
Ah, yeah. Of course, I also agree with that point. And by the way, to be honest, the scenario that we developed was very, very simple. It's quite simple, and it's just like the standard safety in school. I believe that for industry or for office, it requires more steps. It requires a more complex scenario, and further investigations are required.
I had a question about the experiment on the geography via environment. Do you have access to actual students who actually have to learn this kind of things like high school students, maybe? Or you are just using master students from your environment?
Pardon? I didn't really get the question.
The subject
yeah.
of your geography experiment?
Yeah, the subjects
You
were
access
all high
your
school
students?
students.
Yeah, sorry?
All of the participants were high school students.
Okay, so that's good. You had real, sort of more real subject. Okay.
Yeah.
Is it difficult to access students from high school in Indonesia? Because in France, it's very difficult to get into the education system to work with subjects.
Well, this is just because I was quite lucky because my master students who works with me are teachers. So they are the teachers on that school. So they have direct access to the participants.
Okay. It's not difficult normally. Okay.
Okay.
Yes, that's a good opportunity.
Another question on WebEx. I have another question here.
I want to emphasize some things with cognitive 3D. I think today you've got the option of having a high-level analytics tool to explore AR and VR. Some of them are open source and some of them are
subscription plan.
Yeah, you have to pay for them, which is the case for cognitive 3D. And
Yes.
And that's interesting, but you don't have the control on what you are doing. Psi is more like a low-level way to record in a standard way your raw inputs. So you have to choose if you want to write code and make your own analytics using Psi, or if you want some things like ready to use but with the inner limitation of just having the available components. Yeah, so I think that's two options between low level and high level programming.
Yeah, I don't know if 3D is, if it's probably just a black box where you record things and analyze with their tools, but you can do anything else. They have got their own format of data. That is not the case with Psi, as you can just transfer it into CSV or JSON files.
Okay.
That's a long-term question because when you start to do your experiments with one or the others, then you don't change. It's very costly to change your analytics environment. So yeah, it's an important question.
Yeah, to be honest, this is gonna be our first time utilizing these tools. So we have never used the PSI. We have never used this cognitive 3D. the importance note from you is a very beneficial for us, and we would like to put it into serious consideration. Thank you.
Thank you. Still no question on the WebEx side, so we might move for the next presentation. Thank you, Adzik, for this presentation again. It was really interesting. I propose a 5-minute breaks, time to set up, and we'll go for this.
Tu travailles avec Atlantique?
J'ai commencé à lui envoyer des trucs.
Merci. Ça va, ça va.
Oui, bah, je suis allé juste.
Ouais. Moi j'ai l'impression que là il a des questions. Ah ouais, c'est excellent. Ouais, mais là pour l'instant, n'importe quel, que ce soit pour un projet de recherche, un projet d'éducation, peu importe finalement l'obligation. C'est ce qui est cool, c'est que ça va aller n'importe où. Ah, toi tu t'es expert. Pas manipuler tous les sens. Oui. Oui. Quel département IT, c'est vrai que tu vois, tu travailles elle est rigole la production, on va la partager après sur il revient après. Ah, mais je crois que personne ne fait de la même. Et dire, poste, pour les faits, tu vois. En fait, c'est j'ai vu des projets IA, chez ça, c'est le radiologue qui est avec qui accompagne qui marie en fait Come on. Non, moi, moi j'avais prévu 17h et il m'a dit poste du volet de
one or this one.
J'ai le rattrapage à 16h30. Je laisse la partie ensemble. Comment ça s'appelle du coup avec. J'appelle comment les choses que pas par professionnel.
Stop not working.
Okay.
No.
Tu vas te dire aussi. Radio. Agus vous dit radio. Vous dit radio. One c'est French. Bravo.
Agus is French for.
Agus is just teacher. Tu diffuses sur réseaux?
Non. Non, je
Et le 600.
Je vais pas sur les deux chaînes, je sur les deuxièmes.
Oui, mais c'est combien de deuxièmes?
Wait for Anthony. Ce sera.
Oui.
Non.
Il y a plus de gens d'université que de l'école.
Ah, ça pique, hein. Là, t'as le Mettre international de
Détecter des comportements depuis les mécaniques.
Ouais, je vais un petit WhatsApp.
C'est quoi? Ah, je l'envoie. Okay, so we will start our second presentation with Agus. So Agus will talk about AI, some case studies that he will work at, that he's working at ETS. So Agus, let's start the fun.
Thank you, Aurelien. Bonjour à toutes et à tous. So good morning, everyone, and good afternoon in Indonesia. Sorry, maybe I will sit over here so that the participant in Indonesia can see my face and voice. So my name is Agus. Well, and today I will talk about the challenge of implementing data science projects in developing country. Some case study in Indonesia, and maybe later I will mention there is a project that collaborate with Philippines and Japan. Well, this presentation or today's seminar is thank you to IMT Atlantique, team of Cedric, Pax as design, and as well provide. I'm here from the scholarship. I'm a research invited researcher from PHC Nusantara. It's a collaboration between Indonesian and French government, and as well as under the umbrella of PSEM, France-Indonesia Collaborative. And yes, okay, just for the preliminary and disclaimer, all projects have been published, so it's a public information with me either as a lead, supervisor, or team member. And maybe if we talk about implementation and application when you are writing a title in paper, well, when we talk implementation, something we build something new. So in this case, I refer to implement keyword because something specific related to the context we are tackling. And then as well as there is a difference between data science and AI. I will explain it later. And these examples, actually, it's only highlight a few of many challenges. So actually, maybe it's not really related, or maybe not really related. Just other remaining and unmentioned. So just to make sure that a lot of challenges exist. And maybe this one is unique to this context. Either it's applied for developing countries, or maybe it's general issues, neither there is no background countries, etc. So when I mention developing countries, actually the definition in Wikipedia, there is no clear argument, but I would like to say low and middle income country, as Indonesia lies in this area. So the solution proposed will consider this perspective. And when we talk about data science, AI, actually it's like an intersection. When AI specified with intelligence system, but for data science it's interdisciplinary field. So you have a problem, it can be solved either by mathematics, statistics, or computer approach, and we combine it to each other. So it's more general. And yes, why I mentioned I bring this topic today, because I think it's globally since the generative AI, LLM, etc. So a lot of people, a lot of enterprise want to compete to build like new technology. As we know, a lot of companies like Huawei, like Microsoft, OpenAI, they have major research and major innovation over there. So as well as in countries. But the challenge, if we consider for example, in Indonesia, there are at least 4 perspectives. The first one is the data. It consists of limit, unstructured, private, and then the hardware, and then skill gap, and then social culture. I will explain it through examples. So I will talk about these 4. So this is the first case study that I mentioned. When we talk about the data, often the problem is that the data is limited. Unstructured data, there are a lot of data, but it's unstructured, not connecting between each other, or the data is private. So this is the research from my PhD student. This is the topic widely speaking in social media, spread of dangerous speech. So when we talk about dangerous speech on social media, it's everywhere, sentiment analysis, etc. What makes it special in Indonesia? Because in Indonesia, historically, we are built from a lot of tribes. As you can see, and we have a lot of around 1,000 ethnic groups and 700 living language spoken. So yeah, if you are posting something in English or in French, maybe it's quite easy, relatively, I don't say it's relatively easy to analyze. But in Indonesia, we have combining, mixing between dialect, between accent, etc., and language. And since we have a little bit our culture, maybe I think it's historical culture. So there are several cases that about there's a provocation in social media continued to the battle between 2 groups or more in real case. Yeah, this is just 2024. You see that long sword from the students, and this is what we propose. So people of Indonesia, they use a lot of they use social media. They have mobile smartphone, but most of them don't have laptop. Well, some of them don't have laptop, especially in rural area. But smartphone is accessible. So to mention or to see to categorize dangerous speech, we split it into 7 groups in the context of social context, historical context. For example, when we talk about the historical context, dangerous speech, and social media. So maybe it's like talking about World War II or genocide. Well, if we relate it to in the Europe, in Indonesia, it's like in the colonization, or maybe about the historical of economic crisis where certain ethnic is attacked due to like false image of, oh, they are rich ethnic, so we will attack them because they make our country collapse. So there was a story over there in 1998. So yes, that's historical context. Next, if we consider the message, there are 5 aspects to consider. The dehumanization, like, yes, talking like he's like, sorry, animal or something, accusing some in a mirror, assertion of attack against women, questioning group loyalty, integrity, or purity. So yes, it's quite sensitive when we talk about this, and if we if we can consider, especially if it's said by famous influencer or famous people. Therefore, we try to identify the dangerous speech. Yes, normally when we process natural language processing, there are how to say, general steps include. But in here, since the language contains of Indonesian language, which mixing with local language, so we have to do a lot of data filtering, cleaning data sets. We have like 96,000 of tweets data, and we couldn't label it all. Yeah, it's limited data, so we asked social science professor to label like 2,000, and then we put it to the machine learning. We retrain it again. And then we have to select the slang word, what's the meaning of this one, as well as the abbreviation, because it's differ between one language, one local language to another local language. Even the meaning, when I say like word dahar means eat. It's polite in Java, but in East Java. But when I say dahar in West Java, it's impolite. But for impolite. So yes, that's quite challenging. Well, this is our first challenge when we consider the data and related to the language. Next, still with the data. So last year, I was asked by clients that they, well, it's a company, big company in Indonesia in fertilizer. So they need to justify, or they need to learn whether the price of the fertilizer they produce are influenced by the global trends. Because when you couldn't sell, when we talk about selling fertilizer export in area, you couldn't sell, oh, I have this price, then I sell this one. No, you have to follow the market price. So therefore, they need to set the next year whether they don't want to be overestimate or maybe not underestimate. So it's less decreasing the production, like production motivation. The problem is that the sales data for each region, several competitors are not available. They are not provided yet. And the second one, actually, it's already, there is a data analysis player in fertilizer, it's global fertilizer. But you see, well, they are a monopoly player and return to the private data, so they don't provide it. So in this case, this company want to be more, little bit independent in terms of learning the consideration. So we propose external factors like stock prices instead of asking about the data of competitor. We see their stock price because stock is public data, and season because it's fertilizer. tropical, subtropical, it's different. Global and national events, maybe like the election, like last week the election of Trump, and then the election of Indonesian president. That it gives an impact, COVID, and Russia, Ukraine, and commodity price. And then we try to do like some forecasting approach, cleaning, adjusting. According to this data, actually it's quite interesting. COVID, COVID, yes, it impacts the selling. First of all, it's going down, but later it's going up. And Russia-Ukraine war, since Russia and Ukraine is a lot of, they are a big player in gas, and yeah, gas related to the fertilizer. Yes, it's increasing the price. But actually, the one that impacts the higher price is not the war, but the sorry, I forgot to mention the export restriction. You see, when we have limited resource, maybe I remember in India, in China, they limit the export, so the demand remains same, but there is not a lot of each country keep the price, keep the product fertilizer, so that the price spikes and it becomes very high for this year. What about for next year? That's what they want to see, because for this year they have they get a lot of returns, salary profits, but you see, normally when we target a company, also next year, this year you got 1 million euro. Next year you have to get at least the same 1 million euro. So they couldn't say no without any justification, and that's this data science provide to justify. Okay. Next experience on data science is about this one, the hardware limitation. Actually, when we talk about hardware, well, first it's the cost of the hardware. 10,000 euro is expensive. So yes, that's the first. But I think it's realized for all. The second one is the policy. Like in Indonesia, we have TKDN, is domestic component level policy. That's why iPhone 16 is banned in Indonesia right now, since there is they couldn't provide. Apple couldn't provide the KDN level, and then sometimes it's not about the budget itself, but since it's still in proof of concept, the company doesn't want to risk a lot of money, so they just keep a small amount of money. Therefore, so well, this one, this is the case study. This is PDAM is the water company that provide a national water company that provide water to citizens. So the problem starts with the population growth rate in Surabaya. As Hazik mentioned before, that Indonesia, Java Island is highly dense populated in the world. And as well as Surabaya is the capital of East Java, one of the largest population. It's 2 times or 3 times of the population of Nong. So the population growth rate relates to the increased demand for clean water. But PDAM, the water supply company, couldn't provide all with the same price, since they have for the house or for residential area, it's a subsidy policy. So what PDAM needs to collect is that we have to determine whether this water matter is it's owned by the business. This one is owned by residential. In France, if I remember, if you want to open a business, you have a lot of legal document. But in Indonesia, if you open a home business, just convert your home to the business, your cafe. So well, it's possible to do that, and certain amount, and certain level, and maybe sometimes after it's viral, etc., still it's classified as a home. So yes, PDAM want to do visual recognition, do a direct survey for all customers. The current solution exists, is that deploying the personnel, but it takes high labor and takes time. The second one is mobile mapping technology, like using Google Car to see Google Map cars, but it's quite expensive. The LiDAR, etc. We bought it once, quite expensive. So, okay, it's not the option in Indonesian company, normally in local company provided by government. So what we propose a low-cost webcam camera and GNSS integration. You see, when we face about the cost limitation, sometimes the innovation is not really new innovation, but it's the low-cost version innovation. So this one integrating and updating home data using AI principle. This is me who designed the AI part. It's led by professor in geomatics engineering. So to put it simple, you have Google Maps, just like street view photos, and then we want to take, as you can see, it's only one home, so we don't want to take all three, because if we take these three data, we call Google Maps API, circuit share. It will be expensive. So we select, check the image similarity, custom hyperparameter, doing some iteration, and using PJJ pre-trained learning, and then to extract. After all, at the end, we got a unique represented home or a building, and then call Google Maps API to take the address, because we have this one GNSS integration. After that, we relate it to the database of water supply to the PDAM. So that's what we did. Interesting part is that we couldn't use GPS. Like, why don't we use like a phone GPS? The error rate in phone GPS is like a 6 meter, around 6 meter. This one is the existing solution. Sorry, it's a little bit small. The red dot, it's GPS, using GPS. And the green dot, it's using GNSS. GNSS is less than 1 meter, like 70 meter, even 10 centimeter. So yes, we are able to detect more accurate. Why this is important? Because in Indonesia, dense population, there is no gap between its house or business building. So it's directly, you don't want to be paid. You don't want to be classified. Your home, maybe your home is classified as a business because it's beside the business store. So to minimize this kind of problem, that's why we need GNSS to make it more accurate. So this is some experiment, and it provides good result actually. This is just give some little bit video. So you see, they just use we just use a tripod and painting below, and then put the webcam in 3 or 4 side. And he said, we have GNSS. Let's see this tripod, and then collect the data, and then put into the machine learning, pre-train it, and generate the address, match it with the PDAM data. So this is our solution. Later, these tools, these tools is extended with the collaboration. It's extended in agriculture area in collaboration with Philippines and with Japan. So to measure the stock and put it to the drone with a backpack LiDAR. So you see, because Indonesia, it's not only dense, but within the dense area, you got a small road which car couldn't pass. So yes, you have to walk. Yeah, that's the challenge about the geographical characteristic of Indonesia, especially in big city like Surabaya. Next, it's about the skill gap. Actually, when we talk about skills gap, it's not it doesn't mean that the person, the client, they don't have any, they are beginner or something. They are experts, experienced in several, a lot of years, and they are subject matter expert. But they are new to the data science and the machine learning AI implementation. And other than that, there is a movement, and big companies in Indonesia, they create a new division called digital transformation. It's quite good, well, for informatics, consulting, to provide a lot of chat to collaborate. And next for the deployment also, because normally research paper and professor in university, they stop in evaluation, doing this, the accuracy, etc. So yes, we continue after publishing a paper, continue to deploy the solution. Whenever there's a problem, well, to put it simple, it's not that simple, but to put it simple, do you have any coding experience or in-house expert in your company? If yes, then we propose the coding approach. Well, this one I mentioned Python. If no, then we, if no, actually we ask again whether you want to participate directly, because during the consultation, like to the doctor, sometimes you are eager to know what causes my problem, etc., how to solve this one. There's consultation. So sometimes they want to engage up to technical area. If they want to engage, then we propose to use a low code, no code, at least from the beginning. So we train them to use it, and then after that they notice that, oh, okay, I need this data need to be clean. What does the meaning of this data, etc. So they are the subject of, they're the expert of the data. Just facilitate them to do. Then after that, we got some iteration, got solution, with deployment. So this is just plug and play, not just plug and play approach. If you want to use AI, machine learning, data science approach. As you can see, starting from the data, you drag and drop, and then configure the parameters, and then load the data and play. It will be run like this. Disclaimer: this solution, this is in GNOME. It's open source, and some big companies in Indonesia start to use this one for the non-IT domain. Well, of course, there is some limitation, but at least these four are some example of what we did. We assist PLN is a DF, electrical company in Indonesia, national company. They need to do a lot of things. They have digital transformation vision, so they can use identification of feature predicting prepaid electricity. In Indonesia, the electricity, well, there is a certain level for customer, home, resident, and business. And then there is a prepaid version and postpaid version. The old way is the postpaid, and they want to change it to the prepaid. So they pay first, then use the electricity. And then utilizing machine learning for clustering and predicting prepaid customer power upgrade targets. So this one is to target the postpaid, to change to the prepaid. Because current approach, they just, okay, we have 10,000 target. We have 1,000 staff, sorry, we have 100 staff. Then every, this month we target 500. What's the priority? There is no priority. They just put it either randomly or just the nearest approach, nearest area from the office. And then as well as this one, outage report, because in Indonesia we have a lot, we are actually paying data of the disaster also. We have earthquake, we have flood, etc. So outage report, etc. is quite common, large or small case. Okay, that's what we did to tackle the challenge and the skill gap. And last but not least, this one. Yes, by the end, it's return to the social culture of the people, or it relates to the occupation, what kind of job they have, the local economy, and the social condition. Actually, there is a problem owner from one of the national bank in Indonesia. They need to take strategic steps to mitigate the potential risk post-COVID. When we mention potential risk, is a non-performing loan, so giving the loan and not paying. And it's in Bali branch, so in Bali Island. You see, during pandemic, during COVID time, one of the most impact area is the tourist side. So Bali is highly impact. So they want to mitigate the risk as well as expanding the new business strategy. So to ensure both successful business expansion and effective risk, it's necessary to group the debtor profiles according to certain characteristics. So, what of course there is a standard, global standard from Indonesian Bank, the Federal Bank of Indonesia, and for its every person there is a label that's this is optimistic. We can give it the loan or not, etc. There is a record and there is a matrix of evaluation, but it's not enough. So we have to consider further. For example, how long they become the debtor, and then the kind of credit they take, and then the purpose of the credit, where is their location, whether it's in Denpasar, the capital city, or in Tabanan, it's in agricultural area, residential area, and as well as the type of their occupation, whether it's in trade, in service, hotel, accommodation, transport, etc. So by the end, we propose this one, customer profile analysis using clustering for risk mitigation and small, medium enterprise, great portfolio expansion. Since a lot of, when we talk about majority of Indonesian business area, it's in small, medium enterprise. And a lot of them are sometimes, a lot of them are not listed in taxpayer for the business. So yes, it's quite challenging. We created two clusters. The first cluster is for expanding business, and the second cluster of on the mitigation risk. For the expanding business, actually, well, this is the silver score. It's quite good, 0.696. The maximum score is 1. The maximum score is 1. So, and this one, I just put one characteristic of the top priority for expanding business, which is the debtors that have been client for 2 to 4 years. And the business is services and trade, not in the hotel or accommodation. And not only using credit for working capital, but also for investment purpose. And this is the top priority expanding business. And then less non-performing loan. So we give the loan, but we have to take, this is the priority. So the debtor lacks reserve funds. They don't have a reserve fund to pay for installment, but they receive payment relief. There is like a kind of insurance from the bank, which still offer optimism. So it means that the bank assume, oh, this guy will pay. Then their business are in agriculture in Tabanan. So it means that, okay, so we prefer to give a loan to the agriculture business area other than in the hotel, etc. So yes, that's what we find out. Actually, this one, previously when we talk about the data, there is a limitation, a characteristic of Indonesian economy, geographical area, etc. But what if, this is the example of full power data science implementation, means that still in Indonesia, they have full support of the money, they have full support of the skill, they have full support of the data, and there is no barrier for the social culture. So This is for this case. I'm not the one, of course. I'm not the one doing this. I'm the jury. SKK Migas is the special unit direct under president that has the responsibility to manage the oil and oil and gas extraction or production. So they create an AI machine learning hackathon, and the participants come from like Chevron. Well, there is no more Chevron, I think. British Petroleum, from Pertamina, it's Indonesian national company, and then from Exxon and a lot of petroleum companies. One of the solution, it's quite interesting because they can provide like they can optimize like 53 million euro around per year, because they have, for example, this one, it's previously owned by Chevron and then converted to Pertamina, to Indonesian nationality. And then the problem is that the oil mining is quite old, and 99% is water, 1% is oil. So how to extract, how to explore the oil production over there. So they provide machine learning approach to learn the sedimentation, signal processing of the sediment below, etc. Normally, using the human expert, it takes 1 week to evaluate 4 oil mining spot, and with AI, it's on around in 2023, it's around 700 oil mining at the same time. Well, at least one oil mining can be done within 2 hours and can be duplicated. So yes, that's one of the nice implementation. And this is my takeaways: how to implement or apply data science, especially in Indonesia, according to my 2 cents experience. The first one is to use framework. For example, like CRISPR, it's IBM provided. So, well, a lot of CRISPR, cross research industry standard process for data mining, to make sure that you are not missing some step, like data preparation, data understanding, what kind of cleaning of data, what kind of cleaning we can use, etc. Why a lot of problems they just go, okay, what kind of machine learning we will use? What kind of I have this problem, what kind of solution, etc. And then define measurable outcome. It has to be quantitative, and determine the problem owner and or subject matter expert. Don't stay with your own assumption. Assumption kills. And it will be more sustainable if there is an in-house expert, because machine learning requires frequent retraining. For software, you develop software, give to the customer, and then try it with dummy data. It works, and then during 6 months, maybe 1 to 3 times for maintenance. But after all, it works. But for machine learning, given the same given the same algorithm, change the day, it changes the trend. And then there is no silver bullet, so you have to pay attention with specific context and stay hungry, stay with this. I think that's all from me. Thank you very much.
Thank you, Gus. Do we have any question? So, not on WebEx yet, but here.
Hello. I was wondering, you were saying that in Indonesia, one of the reasons why there is a skill gap is that people don't have much access to laptops, but the smartphones are readily available.
Oh, okay.
And do you think that, like, from your opinion, is the skill gap decreasing since smartphones have become available? Like, are business people more aware of how computer science works and such?
Okay. Thank you for the question. Interesting. So when I talk about the skill gap, actually it's different type. skill gap over here is the skill gap to apply in the context of business. So they're already in the company, they're already stuck, etc. They have access of full laptop, computer, etc. The skill gap, what I mentioned that for that is that they don't have enough experience of doing machine learning.
Very specific to machine learning. It's not just computer, because I thought you were talking like maybe smaller companies or like 5-10 people that don't have a group, their own computer scientist. And, okay,
Yes.
More a big company.
Yeah, for small people, yes, they don't have. Well, I think I have this example hidden. So this is like small medium enterprise company. It's traditional shrimp farming. They have access to the mobile phone. They don't have access to the laptop. They don't have any knowledge about even mathematics, statistics skill. They don't have because they are it's traditional approach. So what I propose, what we approach over here is that we provide like end-to-end solution, just like installing application for them. This is to detect the shrimp pond, etc. And then as well as we provide, for this case, we provide the hardware. And then first of all, we have like doing a trial. For this case, it's quite intensive. We have to assist them, and then we measure after, for example, after 1 week, it's got the increasing rate of income, so it's quite good. After that, they start to aware. Well, yes, this is the interesting part. When handling with people, sometimes they don't aware what kind of technology I can use that. Once they know the benefits, they start to have a more concern, and once they have more concern, they have more like increasing. That's the assisting that what we did.
Thank you.
You're welcome.
Oh, thank you. I guess you give lots of examples. That was really interesting. The first one was really impressive. Like, do you manage to translate the 700 language?
No.
So what is the limit? I mean, that's the first limitation. Like there is a lot of tweet or whatever social network you get. You just cannot translate.
Actually, we state in our research, we state that we use Indonesian language, but since it's social media, even Indonesian people, they use several mixing language.
So how do you? So how do you deal with that?
How we deal with that? Especially we gave like quite 2,400 various data to the professor, so in social science, to label it, so expert labeling.
It was everything in one language.
Sorry?
It was all in the same language.
Yeah. Basically, it's one language, but just like one, when we want to curse something, sometimes we will be mixing the words, etc. So yes, the social professor, they have a previous background in that area. Not for the language capability, but the term one or two.
So there is one social science professor who actually annotated 2,500.
Yeah, it mainly leads to
in one of those 7 categories.
Yeah, currently it's only one social science professor. Well, actually, it's not good practice because it leads a bias perspective.
I'm not sure it's relevant, but do you think about using like the Amazon mechanical turk? Yeah. Like lots of people in Indonesia.
Yeah, and the approach of crowdsourcing, actually it relates to my dissertation. We did something like that for students since we have quite a lot of students, so we asked them to label it and then give the return value. But yes, it's still challenge to label 96,000 data.
Okay. And did you make your own low tech, low cost Amazon
Mechanical Turk?
and this one?
Yeah, we just okay. This is the Google Drive access. Try to limit. So for you, it's line this one and up to this one. For you, line this one to up to this one. Something like that. Traditional approach. Okay. Yes.
So you can show me the example of the GNSS and webcam system for getting the images and addresses to do if it's business or if it's home. So I understand the acquisition system, but once you have the images, how do you determine if it's business or if it's a home? Did you analyze the images and how are they analyzed?
Yes, we use pre-trained data to determine whether it's home and it's business. Actually, there's open data set for home and business. Unfortunately, the data set, a lot of data sets come from either in US or Europe or in Japan. So it's the building characteristics is quite different. So yes, for that case, I asked some students to collect just to get the photo. This is a business area, this is home area, to retrain it again. That's what we did. Okay.
What was the actually? It was the Chinese system you used for the GNSS. Which system was that?
No. The GNSS we use a combination of European station. Sorry, I'm not the expert in GNSS area, but combining the European satellite and I think it's Russian satellite also to provide.
No question on WebEx, so we can continue here.
Maybe one more on this one. So maybe it's not related, but do you have do you have a governance body in Indonesia that is responsible in mapping the country?
Yes, we have
official maps. Yeah.
Yeah, we have the government body for that.
And they were not interested by that kind of data or that dimension of that.
I don't ask the geomatics engineering, because in geomatics engineering and the professor over there, they have a consortium also that collaborate with the GIS, because the professor occupied in this one is specialized in GIS, but because it's the problem is right now it's a little bit specific, so we have another collaboration using similar approach with that survey GIS survey of Indonesia, but not this one. This one is more in with the water supply company. Well, interesting part is that my previous students, after he graduated doing this thesis, this one as thesis, he continued doing the national government survey.
Okay.
So it's opened the door.
Another question about this one. So you say one way could be to extract the address and call Google Maps API. Don't Indonesia have a public API that can tell you which address is a business and such?
No, we don't have that kind of data. In Google Maps API, we have another properties, but yes, we don't.
More questions? Okay, so thank you, Agus, for this presentation, heavy presentation again. Attic is still here, so thank you again, Attic, for your presentation on XR. We will end the video conference, so thanks everyone for joining us for this seminar, and have a good day. Thank you.